turn my chat back on. All right. Whoa, that was weird. Welcome to our first class. For some reason, I'm always like super nervous for the first class, even though I've taught this so many times. I don't even know how many. I would have to go back and count. I've taught this so many times. Always nervous for the first class. And also, I think the first class is my least favorite just because it's mostly vocabulary. Learning stats is like learning a new language. There's a whole lot of vocabulary. So chapter 1 is almost completely vocabulary. So as I stated in the welcome video, I highly recommend printing off PowerPoints before you come to class and then taking notes directly on them because you can use those notes for the test. So I really recommend that. Plus, it'll have all the graphs, it'll have the data sets, it has all of that stuff on those PowerPoints. So I highly recommend printing those off. Now, every time I teach this class, and I change the PowerPoint slightly before I teach it, and it's usually the day of, like the PowerPoint we're doing today, I changed it this morning. So it's not going to exactly match what you print off, but it'll be pretty darn close. So just letting you know, I really recommend doing that and print it two or three to a page. Otherwise, you're going to have 5 million copies. Like, for example, today's PowerPoint is 41 slides. You don't want 41 pages of paper. So if you put it 2 to 3 on a page, it's going to be a lot less. So I highly recommend that. You can print for free at RCC if you want to do that. Or if you have your own printer. I don't know how many of you have a printer, whatever. So we're going to go through chapter 1 today. That's, as I said, it's basically vocabulary. I'm going to make sure to tell you to star things or highlight things that I think are something you might forget and say, hey, this is definitely going to be on the test. Go ahead and highlight this or star this. Certain things I will tell you to do that. And chapter 2.1, we're going to talk about organizing data. We're going to organize it in bar graphs. We're going to organize it in tables. We're going to organize it in pie charts. We're not going to do any actual math today, no calculating. So you won't need your fancy calculator. Here's my fancy calculator. I have that. And I also, in this class, this is so fancy. I'm like, love this. I have an online emulator right there. So if you are somebody who has not been able to acquire a calculator yet, I have a really strange roundabout way to get to an online calculator emulator that basically another school put up for their students to use, but it's open, wide, and public and free to access. So if you want access to that online calculator, send me a message through Blackboard or an email, and I will give you instructions on how to get to that online calculator. You won't be able to use it for tests, but you could use it for anything else in the class. So send me an email or send me a message through Blackboard if you want access to that online emulator. It's a little too complicated for me to just say in class. I want to give you step by step on how to get there. Okay, so let's get started. I'm going to use my fancy schmancy iPad. Whoa, weird things just happened. I'm going to use my iPad. I'm going to write on it with my Apple Pencil. Thank you, Three Rivers School District, for these lovely tools. I couldn't do it without them. Well, I could, but it wouldn't be as much fun. All right. Oh, maybe. Okay. So let's start out with just what statistics are. I am not going to test you on what statistics means. This is just laying groundwork. So statistics is a science. It's the science of collecting, organizing, summarizing, analyzing information, and we use it to draw conclusions or to answer questions. We also can use it to provide a measure of confidence. So what you have seen this, I'm sure, in polls with, this is an election year. So you see all sorts of polls everywhere, and it'll say something like, this person has 48% of the vote, plus or minus 7%. So, and what they don't give you is the confidence level, which was like, that's a 95% chance that it is between those two values, the 7% below and 7% above. So that's what we're going to be doing in this class. We're going to be saying something like, I am 95% sure that this candidate has 48% of the vote, plus or minus 7%. So that's what we're going to be doing in this class. That's going to be a few weeks down the road. I think that's like week 6. So I use the words data and data interchangeably. I don't even know which one is right anymore, and I don't even care. I say it both ways. And I sometimes in the same sentence, I will say data and data. See, I just did it. And one thing that's really annoying is that data is a plural word. So you could say the data are, and that's really annoying to me. Most of the times I'll just use it singular, but technically it's plural and it's just annoying. So the data is just the stuff that you collect. It can be numerical, like height, or it can be non-numerical, like gender or left or right-handed, things like that. We're using these things to describe the characteristic of something. And I wish that that thing, let me go back. I don't know why this little thing at the bottom won't go away. Let's see if I can get rid of it. Go away. It's usually like gone. I don't know why I can't get rid of it. I don't know. Let me see if I can just make this smaller so you can see. There we go. So we're going to use the data to prove a point to determine whether or not it's being misused. We're going to use it to prove a point is our biggest deal, or to offset anecdotal claims. That's what we're going to be doing in this course. I have no idea why that's there and how to get rid of that right now. I don't know. I'll figure it out. Okay. So this is important. So this page right here, you will be asked questions regarding the things on this page. Okay. So some people use little tabs like Post-it notes or whatever. I don't think, yes, the first test does have something that refers to this question. It just dawned on me. All right. So population is your entire group that you're studying. So for example, if I was going to study, do a study of RCC students to determine if there was a correlation between how much time they studied and the grade they received, our population is all of RCC students. I obviously am not going to be polling every single RCC student, but I will be polling some RCC students. But the population, I am studying all RCC students, so that's my population. Make sure you stop me if you have questions. I'm going to try to stop here and there and let you write things down. But if I move too quickly, please tell me to back up. Please tell me to back up. And please, if you're messaging, message public, because I can't see the ones privately messaged to me until after I stop sharing. So if you're going to message, please message the whole meeting chat, because I won't be able to see the private ones. Okay. Next, sample. So a sample is a subset of the population. So if I poll, let me see here. If I polled 50 RCC students, those 50 RCC students are my sample. That sample I'm going to use to represent the entire population, which is all of the RCC students. But I'm going to only poll 50 of them, because I couldn't imagine trying to poll every single RCC student. That would be really rough. Therefore, I will poll 50 of them, and that's going to be our sample. How in the heck do I get rid of this thing? Can I drag it? Oh, look at that. Thank goodness. All right. Next, we have individual. An individual is one person or object that is a member of the population. So in this case, it would be one RCC student. So one RCC student. So it is one of the things that gives us a data set or a data point. So one data value is the one RCC student's, like how much time they spent studying. So the one RCC student is my individual. I'm going to give you a second to write things down, because you're going to need this. So I'm going to give you a second. Or a minute, probably just a few seconds. Right, unless anyone needs more time, I'm going to move on. Okay. All right. So we're going to give you an example. when I do this in an in-person class, and the funny thing is, I really should have like polled you all ahead of time. I think that would have been really fun. Maybe for fall term, I'll do that. So you're walking down the street and you notice the person in front of you drops $100. Nobody notices the $100 except for you. You could keep the money without anyone knowing, or you can return it to your owner. So if you keep it, nobody is going to know that you kept the money. Would you keep it or return it to your owner? Normally, what I do is I pass out post-it notes and I have everybody write keep or return on the post-it notes. And then I collect them all and they're anonymous. So you would need to be under anonymity. So I don't know how I would poll with an anonymity, but I would figure something out. So I'm going to figure that out for fall term. Anyway, so now take a look. So just a second here. So let's say that I have 30 students in the class. We don't. I think we have 22. But let's say we have 30 students in class. And let's say 26 of them said that they would return the money to the owner. And let me tell you, when I ask high school kids, I get a lot smaller numbers. Usually I get like only 20. Okay, thank you. Thank you very much. I'm going to write that down. Right, thank you so much. Actually, I think I get a copy of the chat also at the end. Anyway, so 26 out of 30 is 86. I'm just going to round it to 87%. So 87% of our class would return the money to owner. So this is just the raw. They just gave me these numbers. I haven't done anything with it. All I'm saying is 87% of our current class would return the money to the owner. This is considered a statistic. It is a numerical summary of a sample. So if I'm thinking that trying to apply this to all RCC students, I am taking the sample data. I have a sample of 30 students and I polled just those 30 students. So a statistic is a numerical summary of just a sample. So you will need this for your homework and for the test. However, I'm going to give you in a couple of slides, I'm going to give you a summary so you can write it down from there. So descriptive statistics is when we actually describe the data through numerical summaries, through tables, graphs. However we display this data, that would be descriptive statistics. You don't need to know the difference between statistics and descriptive statistics. I'm just kind of giving you an idea of the vocabulary. What you do need to know is that a statistic refers to a sample. And your homework will ask you about that. So statistics, sample. The alliteration there should be helpful. Okay, moving on. So we describe the results without drawing any conclusions. Therefore, all we're doing is describing the statistics. We didn't draw any conclusions or do any kind of mathing other than calculating a percent. All right. So once again, 26 out of 30, about 87%. Man, my handwriting is getting worse and worse. Got to be a summer thing. So if I took this and I extended it to the population, then this is inferential statistics. I'm inferring something based on what our class said. So if I'm implying that 87% of all RCC students would return the money to the owner, I'm inferring something based on a sample. So I'm extending it to the population. So we would have to use a level of confidence. So I would have to say, I am 95% sure that 87% plus or minus 3% of RCC students would return the money. So I could say something like somewhere between 84% and 90% would return the money. So you have to, when you are taking a sample and you're using it to infer something about the entire population, you have to have that margin of error in there and your level of confidence. Don't worry, this is stuff that we're going to do in I think it's chapter 9. So this is stuff we're going to do in chapter 9. I'm just kind of giving you foreshadowing, if you will. It's kind of telling you this is where we are going. This is things that are going to happen. So that's what's happening here. Any questions so far? Are we doing okay? Okay. All
Doing
righty.
good.
Yes.
Oh, I just said doing good.
Good, good. Okay, thank you. No, I appreciate it. All
Yep.
right, let's move on. All right. Suppose the percentage of all your students, all the students on your campus who have a job is 84.9%. So this is all students, therefore it is a parameter. A parameter, if I can get the next screen. So a parameter is a numerical summary of a population. Don't worry, I have I think it's the next screen. It puts it all in one. Okay, so Bradley, we have there will be math I will show you in chapter 9 that gives you the plus or minus. Um, I'm just where I just found it was just off the top of my head, I made it up. So there was no math involved on that plus or minus 3%. We're going to do that in chapter 9.
Okay, sounds great. Thank you.
You're welcome. Thanks for the question, because I'm sure other people were sitting there going, I don't know where that came from. Am I going to be tested on this? Don't worry, not testing on it to chapter 9. Way, way, way at the end. Okay. So a parameter refers to a population. A statistic refers to a sample. I don't know if they did it on purpose with the P's together and the S's together, but I am so thankful they did. So this one, if I took a sample of students and found that 86.4% have a job, then this is a statistic because it's based on a sample. So statistic is sample, parameter is population. Here is your right here is the summary of it. This right here, this piece right here, highlight, star, whatever you need to do, you will be asked questions about, is it a statistic or is it a sample? I'll give you a moment, take a drink of water. I swear that this iPad is 800 degrees sitting on my lap. Excuse me if it causes me to sweat. My house isn't that hot, but this iPad. Yes, statistics equals sample. Good. Parameter equals population. Perfect. It's exactly how I would write it in my notes. Good job, Andrea. It's exactly what I would write in my notes if I didn't have the PowerPoint printed. Beautiful. If anybody wants to have the job as the class clown in the chat, it's open. The position is open. It doesn't pay well. It pays in knowledge, but nothing else, and it pays in entertainment for the class. Usually, I have at least one class clown in there, um, making punny jokes or whatever. You're more than welcome. You're more than welcome to interact with each other in the comment in the chat or tell jokes or whatever. People who don't come to the meeting, they miss out on all that fun. So you're more than welcome to once you're feeling a little more comfortable. All right. And you're also more than welcome to recommend good vinyl to me because I am currently obsessed with vinyl records. Okay. So the goal of the inferential statistics, we're trying to use statistics to estimate parameters because usually we can't poll an entire population. Therefore, we use statistics to estimate the population. That's what we're doing here. That is like our goal of the entire class. All right. Unless there's questions, we're going to move on. Okay, maybe. Okay. I am not going to grade you on the process of statistics. You will not need to give me this information back. I just want you to have an idea, especially if you are moving on to 244 after this class. Most people don't. There's like maybe 5% of students take Stats 244. If you're moving on to Stats 244, this is good information. But otherwise, this is just informative. I'm just kind of telling you this is what we do. And it's going to sound a lot like the scientific method. Anybody who's sciencey, which so many people in this class are going to be nurses. You are doing sciencey stuff. So this is going to seem a lot like the scientific method. There's a lot of similarities here. I did say stats is a science. So here we go. First thing you want to do, what is your objective? What question am I trying to answer? What is the population I'm studying? So I need to know what am I trying to figure out? Because why do I collect data if I don't know what I'm trying to figure out? It doesn't make any sense. Therefore, figure out what your research objective is. What am I trying to figure out? What's my question? Next, collect your data. So we generally don't, as I said, we don't conduct research on an entire population. So we usually look at a sample. Once again, chapter 9. Chapter 9, we're going to figure out how big our samples need to be. But for right now, I'm going to tell you how big your samples will need to be. But if you don't collect the data correctly, the conclusions are going to be meaningless. I'm going to give you an example of a very bad way to collect data. I'm going to go on to go on to Fox News, and I'm going to the Fox or the foxnews.com or whatever, and I'm going to put a poll up there that says, do you think Joe Biden is doing a good job as president? This is Fox News. You know what the poll is going to say. This is a bad way to collect data because it is on a place we know it is a conservative news channel. We know the people that who is visiting Fox News. It's going to be very biased data. It's like I'm going to go to MSNBC and I'm going to ask, do you are you voting for Donald Trump? That's good enough. On MSNBC, we know MSNBC is a very liberal news source. Therefore, that poll is going to be biased. So these types of samples, people use them. I mean, you see some things, articles that look reputable. They look like they are really great, well-researched articles, but you need to look at how did they collect their data. Another really terrible way to collect data, if I stood outside Planet Fitness and I asked them if they felt that daily workouts were beneficial to your health, I'm probably going to get very different results than if I stood outside McDonald's and asked people if they thought, I mean, I still probably would get most people saying yes, but you're probably going to get a different types of answers. Or stand outside Planet Fitness and ask, should we stop eating fast food? Stand outside McDonald's and ask that same question. So there's proper ways to collect your data that are going to be less biased, even though most of the time it's really hard to get completely unbiased. All right, sorry. Sometimes I jump on my soapbox and I can't jump back off. Right, next. So this is kind of what I just said here. It's many non-scientific studies. They're based on convenience samples, internet surveys, phone-in polls. If you do a phone-in poll, the people that are going to phone in and answer are people that feel very strongly one way or the other. People who don't really care are not going to call in. People who are really against whatever they're phoning in about or really for, those are going to be the people that call in. So these are not types of sampling methods that are reliable. Right. Simple random samples is what we like. So completely random. Describe the data. So use your descriptive statistics. So we talk about, so we take all of the data and we can use describe our data, kind of like we did saying 87% of our class would give the money back. So you get your overview of the data. Then once you do that, you can determine what types of analysis that I need to use. Next thing I'm going to do is I'm going to analyze the data. I'm going to do all the maths you're going to learn in this term. We're going to do all those maths, and then we're going to take those results and we're going to apply it to our population. That's when I can say, 87% plus or minus 3%. I'm 95% sure that that many will return the money. That was really poorly stated. Don't quote me on that. That was really bad. So then we can report our level of reliability. We can talk about how this applies to the whole population. Do I need to do it? Usually you have like a conclusion, you write your little paragraph or whatever, but this is your process. So looking at this, there's a lot of similarities to the scientific method here. So if you are a science person, you probably are going to do just fine in this class. And if you're really good at reading comprehension and digging into a toolbox to find the right thing that fits, you're probably going to do really well in this class. Or if you're not afraid to ask for help, you're probably going to do fine in this class. Those are the three people that will do best in this class. Please don't be afraid. I am not scary. And if you ask me the same question 8 times, I will answer you 8 times cheerfully. So please do not be afraid. I'm pretty approachable most of the time. Unless I haven't had my coffee yet, don't even talk to me then. But that's usually done and over with by 5 a.m., so you're good. All right. So we're looking at a story right here, and an experiment, whatever. Somebody collected some data and they found their conclusion. We're going to break it into pieces so you can see all those steps. So there's a study that evaluated batterer treatment programs. So they compared the programs to non-therapeutic treatments like community service. These researchers took 376 male criminals, criminal court defendants. Man, that was hard to say for some reason. They were accused of assaulting their intimate female partners. They were randomly assigned to either a control group or a treatment group. The treatment group, they were in a batterer treatment program. The control group, they did community service. After 6 months, 21% of the males in the control group had further battering incidents. 10% of the males in the treatment program had further battering incidents. So based on this study, the researchers concluded that the treatment program was effective. So most of the time when you come down to it and you're like, yes, this was good, this was effective, we're going to apply this to everything. Most of the time they're like, do it again and see if you can get the same outcome, which is exactly what we do in science. You do some sort of an experiment and you're like, yes, this is exactly what I wanted to happen when I did this experiment. And I'm like, okay, do it again. Can you replicate those results? Unfortunately, that's what we do. So let's break this down into all of our pieces. First thing we do, identify our research objective. In this case, we're trying to determine whether the batterer treatment program was more effective in reducing the reoccurrence of abuse than community service. So that's what we're doing. We're trying to see if the batterer treatment program was effective. That's our research objective. After this, so they didn't even take their data yet. All they did was say, this is what we want to figure out. Collect the information needed to answer the question. So we took our 576 people, we put half of them into the batterer treatment program and half of them into community service. And we randomly divided them. That is so important. Randomly divided. Simple random samples. This is great. 6 months later, we took a look at them and said who returned to battering their female partner. So see, we didn't draw any conclusions yet. All we did was collected our data. Next, describe, organize, summarize. So after 6 months, 21% of the males in the control group and 10% of the males in the treatment group had further battering incidents. I still did not draw a conclusion. We just compiled our data. This is the summary. This is what came out of it. This is what we observed. This is our observations. Now, if we were doing, there's obviously other ways to analyze the data, but for this particular study, this is what worked. Next, finally, draw our conclusions. We extended the results to the population. So now we say that males who batter their female partner and participate in a batterer treatment program are less likely to batter again. The word batter, the more I say it, the more it sounds like I'm talking pancakes, but there's so much darkness in stats. If you read through your textbooks through some of the problems in the back, the ends of each chapter, there's so much darkness. Some of these questions are super dark, and you're like, why would they put this in a book? I call them the dead baby problems because there's so many that are about car seats and things like that, and car crashes and all of that. And I don't include those in my slides because they just make me sad. But that's what stats is used for, is to determine safety of things like car seats and where kids ride in the car and things like that. That's one of the main uses here. All right. Whew, moving on. Okay, some more vocabulary. Y'all are doing great. You're hanging in there. Good job. You're getting through the boring vocabulary lesson so we can get to the fun stuff. The fun stuff, I think we get to start doing math on Thursday. And then next week, chapter 4 is my favorite. So chapter 4, chapter 4 is one of my favorite. You guys have some stuff to look forward to, plus our lab on Thursday. Talk about that at the end. Okay, first, variables. You've all been in algebra, you know a variable is things that can vary, variables vary. Our variables in this class will be the characteristic, like are they right-handed or left-handed? What color hair do they have? What color eyes do they have? How tall are they? Those are our variables in this particular class. Variables vary. If everybody was the same height or all plants grew the same, we wouldn't even need stats. And I would be sad because I like stats. Okay, these are important. So these are stars. You will be asked questions about these. Qualitative or categorical. I usually say categorical. That's usually what I say. But I know that his variousness, I love it. That is awesome. His variousness sounds very regal. All right, so when things are generally words or they're numbers that you don't math with, this would be a categorical or a qualitative variable. So think for qualitative, think quality rather than quantity. It's a quality. So a quality, they're effervescent, that's a quality. Categorical, it's categories. Here's some examples. Gender, zip code, hair color, birth date. Sometimes we'll use birth date and do math with it. If we do, then it moves it to quantitative. But in general, birth date is just a day and it doesn't really mean anything. Zip code, we don't do math with zip code. So that's another number that does not mean a number. Gender, birth date. So it's usually words. It's usually things that are not numbers, or it's numbers you don't do math with. Phone number. I wouldn't do math with a phone number. Probably not. Next, quantitative. So think quantities. That's a really ugly star. That is really ugly. I need to get rid of that star. I don't like it. Switch to blue. That's still an ugly star. We're going to leave it ugly. Okay. So these are numerical measures. This is numbers you can do math with. So temperature, number of days a student has studied, weight, height, etc. So numbers you do math with. So I'm going to give you a second to write them down because you will be asked questions about these in your homework and maybe a quiz or a test. I don't know. I'll give you a moment. We've been out of school for a month, so I'm not used to talking this much. By the end, I'm going to need like drink some tea or something. No, it's kind of hot for hot tea, and hot tea would be what I need. It's okay. We're doing great. Y'all are doing fantastic. Okay. Any questions so far before I move on? Okay. So let's take a look at some examples here. So Elizabeth Kavavic, she's a researcher with a cool name. She looked at factors that affect eating habits of adults in their mid-30s. Man, I haven't seen mid-30s in ages. So she looks at the different variables that were considered, and we're looking at whether or not they're qualitative or quantitative. So remember, qualitative is categorical, same thing. So nationality definitely would be qualitative or categorical because it's not numbers. It's just words. I mean, your nationality, you could be Irish, English, German. That's me. You could be whatever, Italian, whatever. Okay. Number of children you have. So I can have twice as many children as somebody else. That's a number that I do math with, therefore it's quantitative. So just think if you would get meaningful results doing math with something. That would be telling you that it's quantitative. Household income in the previous year. You can say I made $3,000 more this year than I made last year. Therefore, we're quantitative because doing math with it makes sense. This one's kind of tricky. So level of education. Now, I have grandchildren who are going into first grade, and I have a grandchild going into third grade, and he is 2 grades higher than the other. So he's technically, I mean, that I technically did math with that and it made sense. But if I'm saying like, I have a bachelor, or I have a master's degree, I do have a bachelor's, but I also have a master's. I have a master's degree, and that person has a doctorate. That's not numbers I do math with. So I'm going to call this qualitative. But in some cases, depending on what you're doing, it could be quantitative, if that makes sense. Like the grandkids, which I will talk about my grandkids a lot because there's almost 8 of them. And when the 8th one's born, darn right, y'all hear about it. And you'll probably see a picture because I know he's going to be beautiful because his parents are beautiful. All right. Daily intake of whole grains measured in grams per day. That's going to be numbers, and you're going to do math with it. So it's going to be quantitative. These make sense? We're doing good? All right. Y'all are doing great. Such troopers. You're putting up with me. Okay. These, yes, you will also need these. So I'm going to put a star here. You will be asked questions about these. Man, my stars are getting worse and worse. It's okay. Let's just pretend it's a beautiful, perfect star. So you may, long time ago in the land of algebra, I don't know how long it's been since you've been in algebra. I mean, it could have been last term for all I know. We talked that you heard about discrete and continuous variables. They mean the same things here. Discrete variables have a finite number of values. If I was going to graph them, I would have to lift my pencil between each value. So they can't take on every possible value between 2 values. Like I have 4 kids. I can't have 3.85 kids. I can have 3 kids or I can have 4 kids. I can't have 3.85. It's discrete. If I was going to graph it, it would look like this on a graph. Or, I mean, I could have things up here or whatever, but it's not going to be a solid line drawn. It's not going to be a continuous line. So discrete would be more like dots on a graph. And it's not necessarily whole numbers because, like, let's say that a ticket to the movie theater is $7.50. I'm not going to spend 8.25. It's going to be 7.50, then it's going to be 15, then it's going to be 22.50, then it's going to be 30. So that would still be discrete because I can't spend 16.95. I can't take on any value. Every time you buy another ticket, it jumps 7.50. So that would be discrete. Okay, let me erase my mess here. So examples, number of students in a class, how many TVs sold last week, number of red marbles in a jar. So it's things that are countable or things that can't take on any value. It's something countable, usually. So, continuous variables. So a continuous variable, if I graph it, it's going to be a solid line. I don't have to lift my pencil to graph it, because it can take on infinite number of values. It can take on every value in between the 2 values. And money, we generally say it's continuous, even though you're not going to have half a penny. But I mean, if you talk to the gas station attendant, apparently you can have 9/10 of a penny. So money would still be continuous, but it can take on all the possible values between 2 values. So heights of students in class, time it takes to get to school, difference travel, weight of a baby at birth. So I can't drive 30 miles unless I drove 28 and a half miles first. So if you think of it like that, I can't be 5'2", which is how tall I am, unless I was at 1.51 and a half. I have to hit every value before I get there. It can't be, how hot is it right now? When my watch says it's 102, it can't be 102 degrees unless it was 100.5 degrees at some point. It has to hit every value to get there. So if I was going to graph it, it's going to look like this. I don't have to lift my pencil to graph it. So qualitative variables live by themselves. Quantitative variables can be either discrete or continuous. Give you a moment to write it down before we move on. We're only on slide 16, but let me tell you, once we get to chapter 2.1, those move pretty quickly. Once we get to section 2.1, I'll go through 3 or 4 slides in 1 minute. It gets pretty fast. Okay. Questions on discrete and continuous? Are we feeling okay? No, first day of class, it's all kind of overwhelming and it'll probably settle in you. And then 10 minutes after the Zoom meeting ends, we'll be like, wait, I should have asked her that. So I'll make sure to check my messages a couple of times before I go to bed tonight so that I can answer any lingering questions. Okay. So once again, we're going to look at the Elizabeth Kavavic and we're going to look at whether these are discrete or continuous and talk about these. So number of children, as I said, can you have 1 more minute? Yes, of course. There we go. Let me know when you're ready. Give you as many minutes as you need.
Melissa,
Yes.
I had a quick question since we're back on that. On the qualitative variables, you said it stands by itself, but then the quantitative, that's supported by the other two, the discrete and the continuous.
Yeah, so quantitative variables are split either into discrete or continuous. They're one or the other.
Oh, okay.
So yeah, they're 2 different like categories, I guess, of quantitative variables.
That makes sense. Thank
Okay.
you.
You're welcome. Thanks for the question. Hannah, are we good or do we need to move on? Okay. All right. Number of children, as I said, it has to be discrete because you're not going to have 3.85 children. Household income in the previous year. I already kind of gave you a heads up on this. We consider money continuous. A lot of the reason for that is because as you're making money, they don't just hand you, I mean, I wish I made 100,000 a year. They don't just hand you $100,000 at the end of the year and say, here, you earned all this, no matter how much you worked, you get all of this. You have to make, you make a little bit along the way. I have to make $5.50 before I can make $6. And yeah, people round it to the nearest 15 minutes or whatever. But if we're splitting hairs here, it is a continuous. The money builds on itself until you have how much money you made that year. So we're going to call it continuous. So I mean, you could make an argument for discrete, but let's just say money here is continuous, unless you're saying how much money do I spend buying t-shirts and each t-shirt is $5. But like income, when you're earning money, continuous. Daily intake of whole grains. So I don't really like these examples. Someday I'm going to change them because this could be continuous. Or if I ate one meal and I ate 1 bite off 1 granola bar and that was my entire meal, I probably was discrete. But you're gradually going to intake the whole grains throughout the day. And I don't really like this one. I think it's at some point, I think I'm probably going to change this, but it makes sense because you're building on it. I have to eat 100 grams before I eat 150 grams or whatever, so it builds on itself. Okay. All right. So I'm going to give you my little disclaimer for levels of measurement. Yes, you'll have questions about this. And I believe there are questions on the test about this. I'm going to talk about the levels of measurement, and I'm going to tell you exactly what I do in my brain to remember them. So I'm going to tell you what I look for to remember the levels of measurement, because otherwise they can be kind of confusing. So, and after the first test, you will never, ever, ever have to answer a question about levels of measurement again. You can forget that they exist after the first test. But just hang on to them till the first test. All right. So nominal. The nominal level of measurement. This is categorical. So I'm going to write, whoa, this is for categorical variables. Okay. for categorical variables. And they don't need to be, don't have to be arranged or ranked in a specific order. So this is like left-handed or right-handed. You don't have to list them in a specific order. If I was looking at people's hair color, red hair, blonde hair, brown hair, black hair, there's no certain order you have to list them in. These are nominal. If they don't need to be ordered or ranked in a certain way, and it's a categorical variable, it is a nominal level of measurement. So, this right here, this right here. So there you go. So here's some examples: gender, handedness, religious, or religion, favorite color. These things, we don't list them in a specific order. I mean, most people will say right-handed or left-handed, but it doesn't matter if you say left-handed or right-handed, it means exactly the same thing. Yes, qualitative and categorical, same thing. Yes. I'll write that. Okay. I think the reason that I use categorical more than qualitative is because that's how I learned it. And you kind of stick with whatever the way you learn things. But yeah, it's a good question. All right. So the next one is also categorical or qualitative. So this is also categorical. Man, my handwriting is really bad here. Good thing I said the word, or otherwise you would be like, I have no idea what that says. So this one requires you to rank them. So allows, not really requires, but allows you to be arrange them. So if I was looking at like level of education and we said, you do elementary school, middle school, high school, associate's degree, bachelor's degree, master's degree, PhD, that's a way that we rank them in a specific order. You usually wouldn't say those out of order. You would rank them in a specific order. Some other examples, your grades, A, B, C, D, F, those are ranked in a certain way. Satisfaction. So you know how they'll say like from 1 to 5, 1 is extremely dissatisfied, 5 is extremely satisfied, where we're ranking them from lowest to highest. Same thing with happiness, things like that. So anything that requires you to rank them in a specific order would be ordinal. I like that the word order is right in it. That kind of makes me happy. So ordinal, ranks, orders, nominal, I don't know. Okay, so these are the only two that are categorical / qualitative. The last two are quantitative. And I'm going to change to my red pen just because I get bored. All right. So the interval level of measurement. This right here is your sentence that is super, super, super important. The value of 0 does not mean absence of quantity, sorry. This is qualitative. Oh, no. Okay, sorry. Bad things happened. Okay. The heck? Okay, there we go. This is quantitative. Sometimes when I lay my hand down on the iPad, it does things. So this is quantitative. So a value of 0 doesn't mean absence of quantity. So a good example is temperature. A temperature of 0 doesn't mean that there's no temperature. It just means it's really cold. The calendar, well, there really was no calendar year 0, but if there was a calendar year 0, it doesn't mean that that's when time started. Elevation and elevation of 0 is just sea level. So the first thing I ask myself is, does a value of 0 mean an absence of quantity? Next, this is important. What math do you do with the number? If the only math that really makes sense is addition and subtraction, it's interval. I'm not going to say it's twice as hot today as it was yesterday. That makes no sense. I could say it's 5 degrees hotter than it was yesterday. I would do addition and subtraction with temperature. I'm not going to say it is twice as hot or half as hot or anything like that. You're not going to do multiplication and division with temperature or calendar years or elevation. So think about, does the value of 0 mean absence of quantity, and what kind of math do you do with it? Those are the two questions I ask myself in order to determine if it's interval. The next one is ratio. This is also quantitative. A value of 0 means absence of quantity. How much money is in your pocket? I don't have any money in my pocket. I have $0 in my pocket. That's an absence of quantity. How many hours of TV did you watch today? I watched 0 hours of TV today. That's an absence of quantity. That's what that means. It means if I say something is 0, it means that it's not there. How tall are you? I'm 0 inches tall. You don't exist. There's an absence of a person. The math that you would do with this, multiplication and division, makes sense. So here's some examples. Money in your pocket. I have twice as much money in my pocket as I did yesterday. Height in feet in inches. That chair is twice as tall as the other chair. Weight in kilograms, time spent watching TV. All of these things, 0 means absence of quantity, and I can do multiplication and division with it. I watched half as much TV today as I did yesterday. That watermelon weighs half as much as the other watermelon. Questions?
I have one really quick.
Okay.
So as far as interval and ratio with the making sense of addition, subtraction, or multiplication and division, is that like a rule as far as there's never going to be a circumstance where you may use one or the other for those, or
I will never
general?
say it is a hard and fast rule,
That's fair.
but what you will learn is that statisticians never deal in absolutes. And it is the most annoying part about stats. We
Yeah.
never deal in absolutes. And it's more of a, I mean, you can pretty much stick by it, especially the zeros. I would say the zeros are the biggest part, the biggest thing that, yes, you can stick by it. There's not gonna be one that's oh, it can be either one.
Yeah.
Generally, the 0 is what gets it for you.
Okay. Awesome. Thank you.
Because elevation, I mean, I've heard people say that a mountain is twice as high as another mountain because the elevation is 2 times the number. So, I mean, I guess technically you could say use multiplication, but a 0 elevation doesn't mean absence of quality or quantity. So that's where it gets you. The 0 is always going to, the 0 is going to give you, I don't want to say always, but the 0 is where it's at.
Okay. And you're not going to like
I'm not
trick
going to
us
trick
as far as the division and okay.
No,
The 0 I understand. Okay.
I am not a person that tries to throw tricks at you. I really don't do that. I don't believe in trying to trick people. I want to know, do you know the stuff? I don't want to trick you. Okay.
Love that. Thank you.
You're welcome. All right. Any other questions before we move on and get rid of this terrible, terrible levels of measurement? No, I mean, it's kind of interesting, but I don't find it super useful, but it is in the standards that I have to teach. So there you go. All right. Moving on. All right, so let's take a look at these. Which level of measurement? Gender. So gender does not, there's no order to gender, and it is definitely categorical, therefore it's nominal because we don't have to order it a certain way. And there's no numbers. Temperature. I hate that I need to use something different because it was on my last one. So a 0 does not mean an absence of quantity. So therefore it is interval. Number of days a college student studied this week. If they studied 0 hours, they did not study. Therefore, the 0 means an absence of quantity. It is ratio. Finally, letter grade earned in stats class you're going to earn an A, B, C, D, or F. Therefore, and those are ordered, therefore it's ordinal. Make sense? All right. I'm ready to blow this particular popsicle stand of levels of measurement. But make sure you are going to be asked some of that on the homework. And I can pretty much guarantee there's a question or two going to be on the test. So if you use like Post-it notes to tab your notes or whatever, you're going to want that there. All right. We're in section 2.1. Woohoo!
I have
Okay.
a question.
Yes.
So our tests that are going to be in Respondus and the notes. So I went ahead and printed off these PowerPoints. Are we able, you said we're able to use these PowerPoints as we take the test in Respondus?
Those are your notes, right? You're writing your notes on them. Yeah.
Okay, awesome.
You're not going to be able to use your book. You can use your calculator and you can use any notes created by you. And by printing them off and writing on them, these PowerPoints have become created by you.
Okay, thank you.
You're welcome. This is why I encourage it. Good job. All right. So we're in section 2.1. If you currently have enough information to complete the first homework assignment. First homework assignment, remember, it is due Thursday. That is your attendance. Your attendance is that assignment. I will check, and if anybody hasn't turned in that assignment, they're marked absent and they are unenrolled. So get that done. Even if, please don't, I mean, I don't really want you to use your late passes yet, but if somebody put a late pass on that, I consider it them here. I consider them present. So, I mean, try to save those late passes, but if you have to use it, you have to use it. So either do the assignment or use a late pass by Thursday. All right. Because Friday, I have to submit attendance. So, and yes.
So to the previous question about being able to use our notes on the test,
Yes.
I have horrific handwriting and hand problems, so I actually type my notes. But if I printed them out and typed them, would that be okay?
You created them, right?
Yes.
So there you go.
Cool, thanks.
You're welcome. I have a lot of people that tell me they do that. And I'm used, just letting you know, I'm a math teacher. I'm used to really bad handwriting. I taught middle school for 3 years and I've taught high school for 6 years. So therefore, handwriting, I am used to it. And let me tell you, the kids with the worst handwriting are the kids that are in like AP calculus. Those kids, I can't read it. So when you're showing your work on your test, please organize it by at least marking it with the numbered problem it is. But I can usually read some pretty bad handwriting. So don't like go out of your way to make it really bad and test me, but I can read some pretty bad handwriting. Just as long as you're labeling, this is question 1, this is question 2, as long as you're labeling them and I can find them, I'm usually pretty good at figuring it out. If I don't know, I'll send you a message and say, what does this say here? But in general, I'm pretty good at deciphering it. Plus, I raised 4 teenagers, so my own children, man, let me tell you. All right. So we're going to be talking about in 2.1, we're dealing with specifically qualitative data. So categorical, qualitative, specifically that. We're going to be looking at a lot of graphs and tables and things. And that's what we're doing here. That's what section 2.1 is about. By the time we're done tonight, you'll be able to do the 2.1 homework. Okay, remember, qualitative/categorical provides measures that categorize or classify individuals. They're generally not numbers. If they are, they're numbers you don't do math with, or that math doesn't make sense. So this is a new thing. So a frequency distribution. So what frequency just means is how often does something show up? So we just list the category of the data and how many times does it show up? How frequently does it show up? That's all it means. So we're taking all of the data and we're distributing it into each category and how frequently it shows up. That's what frequency distribution means. We're distributing our data based on how frequently it shows up. So, raw data. Raw data is data that has not been cooked yet. In your first lab that we're going to talk about more in detail on Thursday, you're required to give me your raw data. Raw data is just listed out. You just list everything. So, like for example, let's say that for my lab on Thursday, I use a bag of Skittles. I'll pull a Skittle out and say that one's green. I put green down. Pull another one out, that one's orange. I write orange down. Pull another one out, it is yellow. I put yellow down. You just put them all down. You don't organize them, nothing. You're just listing your raw data. It hasn't been cooked. It is raw. We haven't done anything to it yet. That's what raw data is. Or raw data, depending on which way you like to say the word. I don't care. So these are ways that we will organize our data. We're going to use tables, graphs, and numerical summaries. So this is the way we're going to look at them. Most of these graphs I'm going to teach you how to do via Excel, and it makes it so much easier than hand drawing anything. Yes, that's why I usually say data, because of data in Star Trek. But I say data also. I say both of them. And high school students get really, really annoyed by that stuff. Trust me. Okay, so on the next slide, we took a bunch of M&Ms and pulled them out of a bag. It's plain M&Ms. We're going to construct a frequency distribution. Don't worry, you don't have to do this. If you printed out the PowerPoints, you're going to have it already. And I'm just going to show you what a frequency distribution looks like. Here's my raw data. Notice it is not organized in any way, shape, or form. It is just all over the place. All right. So what I did was I took my M&Ms and I counted how many of each color there were. So I did tally marks. You don't have to show the tally marks if you don't want to. If you want to show the tally marks, go for it. So I just did the tally marks, and then I counted up how many tally marks I had. And hold on a second here, my other computer is doing wonky things. Okay. So I did the tally marks. I counted up how many there were. This is my frequency distribution right here. Super boring. It's just organizing them. And it's just telling me that I have 12 brown M&Ms and 10 yellow M&Ms and 9 red ones, and so on and so on. So that's all this is. This is a frequency distribution. It's that simple. Okay. Now, relative frequency. So every bag of the mini bag of M&Ms is going to have a different number of M&Ms in them, because it's really annoying and they're like thrown in there with some machine. And so it probably varies by a couple of M&Ms in each bag. So if I say I have 12 brown M&Ms and you only have 13, and you have 13 brown M&Ms, you get so many more than I do. You have a higher percent than I do. We don't know that. In order to compare my 2 bags of M&Ms, we need to kind of standardize it. So I can say this percent of my bag was brown M&Ms, this percent of your bag was M&Ms. So relatively, you had more or whatever. So it is the proportion or percent of observations that were in there. So I can say this percent of my bag was a blue M&M. So we take our frequency. So like this would be my 12 brown M&Ms. And then you would divide it by the sum of all frequencies. So I have 45 M&Ms in my bag. So I would do 12 divided by 45. And I know we've all been calculating percent this way forever. And we're just calling it something else. We're calling it relative frequency. So with a relative frequency distribution, we just take each of those frequencies and we turn them into this proportion or the percent. So you just take how many times the observation occurs and divide it by the total number of things I have. When I math it out, it's going to make a lot more sense to you. So here we go. So I have 45 in my bag. So I took 12 divided by 45, and I got 0.2667 as a percent. That would be 26.67%. I took 10 divided by 45, and I got 0.2 repeating. So I have 22.22%. Now, personally, If you're doing an assignment for me and not in my open math, I don't care which way you give it to me, give me the answer. My open math is picky. Pay attention to the way it's asking for. If there's a percent at the end, give them this. If they just ask for it in decimal, give them this. If they ask for a fraction, give them the other one. Pay attention to what it's asking for. So with red, it's 9 out of 45, which is about 20%, and so on and so on. I just take each number, divide it by 45. This is relative frequency. So that now I can compare my bag of M&Ms to my friend's bag of M&Ms and say, and they would be like, oh, wait, you have 26.67% brown M&Ms. And even though I have 13, that's only 25% of my bag. So now I could say relatively, I have more M&Ms than you do. So I have more brown ones. So there you go. Questions on this? All right. So let's talk about bar graphs. See, we're already on 27 of 41. We're moving quickly. I'm guessing 15 minutes maybe. Okay. So we've seen bar graphs. You guys know what bar graphs look like. I mean, you've probably seen them today. If you watched the news this morning, you definitely saw a bar graph about the temperatures throughout the day, what it was going to look like. It just is what it is. Important things you don't always see in the news, though. You have to label your bar graphs, and I'm going to show you the labels that are required. So every category is labeled either on the horizontal or vertical axis. We usually label the categories on the horizontal axis unless you want to get fancy. And depending on if you want to use frequency or relative frequency, that's what's on the other axis. Our rectangles are all equal width. And then the height of the rectangle shows you how frequently or the relative frequency of the data. Don't worry, I'm going to show you some. It's going to make much more sense than the words. Give you a second to write it down, and then we will move on to some pretty bar graphs because that's what we do.
So you said generally speaking, we're only going to be labeling on the x-axis or the horizontal axis.
No, that's just where your category is going to be labeled. I don't really care if you guys do them the other direction. I just, for consistency purposes, I usually do horizontal, and most people do horizontal just because we're used to it. I'll show you the labels that I'm going to require, I think, on the next page.
Okay.
Not yet. You're welcome. Here, nope. Here's my frequency table. There you go. So labels that are required. So this is exactly what I'm hoping to see from your bar graphs. So this right here would just be, that's the color. So this is the title for the whole graph. Because this right here tells me I am looking at M&Ms, I don't have to say M&M color at the bottom, but I can. But this is just like, what type of data is it? That right there is your label, your axis label. What type of data is it? And then each one of these is a category. Each one of those is a category. And then you have to label. You tell me that this is frequency or relative frequency. I don't know what to write that. Just tell me if that's frequency or relative frequency. Really important. Your graph must start at 0. There will be exceptions to this later, but currently, right now, today, we're starting at 0 always. I'm going to show you how to deal with exceptions to that later. But today, started at 0. Exceptions to that require you to do some funky little symbol that I'm not going to teach you today. So I need to have label for each axis, category labels. Of course, you want the numbers. So this is, I would call that a scale. And then we need to have a title on the top. When you do your lab on Thursday, I'm going to want to see all of these things. I'm going to give you a second to write these down. We will move on. Right. Make sure you holler if you need another moment. Maybe if I can move to the next one. The heck. Okay. I just did that. What the heck? Okay. So relative frequency bar graph, it's going to look exactly the same, except for instead of having the frequency on the horizontal or the vertical, it's going to say relative frequency. And notice that these are going up by the 0.05. So it's going up by 5% instead of by counting by twos. So my scale is 5% each of my tick marks. But the graph, I mean, it's basically identical. It just, except for the relative frequency there. Personally, I like the relative frequency ones because percent means more to me than the count. And it's easier to apply to things. Easier for me to say there's 20% of red M&Ms. Plus, if you go to the Mars website, so just letting you know, FYI, if you go to the Mars website, they give you a breakdown of what percent should be in each bag. And obviously it varies somewhat because it's randomly put in the bags. But if I was to take like 100 bags of M&Ms and figured out the percents, it should really closely match what Mars says. And we've done that experiment in in-person classes before, and mostly just because I wanted M&Ms that day. And so I brought a whole bunch in and had everybody count theirs, and we graphed them, and it was fun because it was really close to what Mars said. Things like that are so fun. This is why the only thing about online classes that is hard. Okay. Yes. So I want to take issue with the word gross, but it makes so much sense in the way that you stated it that I'm kind of okay with it. Though I would say raw data number, but not really raw because we're just going to leave the word gross. I like it. Good job. No, it's okay. I'm just like sitting here I want to take issue with it because it's not exactly right, but it kind of makes more sense than any other word I can come up with. So we're just going to call it good. It's a good job. But yes, Natalie, perfect. Okay. Now, Pareto chart is only thrown in here because I have to. I've never, ever, ever, ever cared about a Pareto chart in my life. So you get one slide. I don't think there's any homework problems, and there's absolutely nothing on the test about this. I think the reason for a Pareto chart is just because someone wanted to make it pretty one day, so they made this and called it something. So if you organize your data in decreasing order so that the highest value is on the left and the lowest value is on the right on your bar graph, it is a Pareto bar graph, and there you go. So I just put the one with the highest percent on the far left and the lowest percent on the far right, and it just steps down, it decreases. So that's all you get from me on a Pareto chart. And I don't think there's a homework question. If there is, I apologize, but that's what it is. So there you go. Some things are just, we're required to teach them. And I'm like, this doesn't even make sense, but yeah, let's just go with it. I'm sure there's things in your job that you have the same thing where you're like, well, this doesn't make sense, but this is the way we do things. So we're going to do it this way. All right. We're almost done. We only have 6 slides left and they're fast. So you all are hanging in there fantastically. I want to use the word stoked, but that tells you how Gen X I am. So let's move on. All right. So we're going to compare 2 data sets. We don't have, how? I didn't even notice that. Oh my gosh. Where did the blue M&Ms go? They should be on the end. So that's that's the takeaway here. Paretos don't get blue M&Ms. Think we found our class clown. Kidding. I love it. Thank you. I have used this exact chart for years. I have never, ever noticed it doesn't have blue. Not a single person has ever mentioned that there's no blue M&Ms on here. OMW. That was awesome. Thank you. Okay. Okay, let's move on. Okay, so comparing two data values. So here I have our in 1990, 40.4% of people were never married. In 2006, 55.3% of people were never married. Or it's not percent, this is numbers in millions. I was like 127.7%. What's up with that? So this is actually numbers in millions. So 40.4 million people had never been married, and 55.3 million people had never been married in 2006. So we're comparing two data sets here. But if you added all of these up, you would see that these are different numbers of people. So comparing 40.4 million to 55.3 million doesn't really mean anything unless you know what percents they are. Therefore, we would use a relative frequency bar graph, and we're going to create a side-by-side bar graph. So you know how to calculate relative frequency. You take the number, divide it by the total number of people that there are, and then you would get your percent or your proportion. So here we have our relative frequency bar graph. So we have percents here. So it looks like about 22% of people were never married in 1990, and about 25% were never married in 2006. It is much easier to compare the two things when they're put in as percents rather than as the gross data, as Natalie would say. So you're much easier to compare it. So I definitely would not try to use frequency for side-by-sides unless your sample sizes are exactly the same or your populations are exactly the same. So, and Excel can do side-by-side bar graphs. It likes them. Will try to do them even when you don't want it to. So it's happy when you do side-by-sides. Okay. Any questions before I move on to pie charts? We only have 3 slides left. Y'all are rock stars. Seriously. Okay. So you've all seen pie charts. So it's divided into sectors. Every sector is a category of data, and it's proportional to the frequency of the category. So I am never going to make you do one of these by hands. Never, ever would do that. Excel does them beautifully, and they have a lot of different fun things to play with. Not all of them are good representations. Some of them are pretty and not super useful, just letting you know. But so it is just a circle. You've seen them. I think that everybody has seen 5.3 million pie charts in their lives, so I'm not going to go any deeper. So we're going to take the marital data from 2006. So I'm going to take that and we're going to put it into a pie chart. So here it is right here. If I was doing this by hand, I would take the circle and say, all right, circle is 360 degrees. 58% of 360 degrees is, I have a calculator here, is 208.8 degrees. So I would use my protractor and I would measure out 208.8 degrees and I would make my little sections. Don't worry, you never have to do this. When you make a pie chart, I highly recommend putting the percents on there because it is a lot easier to read it and to compare things if the percents are on there. Plus, you need to have a key. You've got to have a key. It's important. Es muy importante. And that is it for pie charts. And that is it for our PowerPoint. We hit 41 slides, just about an hour and a half in, and you all did awesome. Before I talk about what you're going to need to collect for the lab, are there any questions on what you've learned today?
You made it all make a lot of sense.
Woohoo! Yay! I love to hear that. Okay, so what you will need for the lab, I'm going to go to another screen so I can write it down. This is the biggest lab we do. This one is worth 30 points because there's 3 different pieces to it. It should not take a super long amount of time. I don't want you to overthink your data sets. Please do not go crazy and spend hours and hours collecting your data sets. What you're going to need, 20 categorical, data values. Data values, data points. So, I don't open up your closet and look at the first 20 things in your closet and write down their colors. Sit out on the front porch of your house if you have traffic that goes by and write down the colors of the cars that go by. Open up a bag of M&Ms and dump them out and write down the colors. I don't care. Please don't go too crazy spending a ton of time on this. Go to NFL.com and look at the main color of the logos of 20 football teams. Whatever you want to do, you know, I'm a football fan. That's why I automatically go to football, like almost every time I go to football. So give me 20 categorical data points. And so that you're going to need that for your lab. You're going to need 20 continuous data values. So the continuous is the only one you're going to use again. You're going to use the continuous in 2 more labs this term. So if you're going to put any time into any of them, just because you're going to look at it again, you might want to use continuous, but it doesn't even really matter. If you're somebody that keeps track of their calorie, look at your past 20 days and write down how many calories you consumed the last 20 days. Look at the temperature over the last 20 days. Look at the rainfall in the last 20 years. Olympics, I don't know what the website is, NBC Olympics or something like that. You could probably find all sorts of data of past like world records or whatever. So just find some 20 continuous data values and throw them in there. And then you need 20 discrete. Remember, discrete is quantitative. Discrete is quantitative. Maybe you could look at 20 soccer games and see how many points were scored. You could, I don't know why I'm drawing a blank all of a sudden. I mean, just anything. You could look at how many pages are in 20 books on your bookshelf. That's a good one. Or I don't know, just find 20 discrete data values. How many kids do 20 of your Facebook friends have? Anything. I mean, yeah. How many years of school 20 of your friends completed? So this is what you're going to need for the lab. You don't necessarily need them on Thursday, but you will need them for the lab. The only reason I say for Thursday is because I'm going to do the lab Thursday. So if you want to like jump right on it after I finish it or work on it along with me, you may want to have yours ready because I'm going to actually do the lab and walk you through it. So that is all I have for you. If you have a question to be asked on the recording, right now is a good time to do that. So we're still being recorded. So if you have something for the good of the group, you feel free to do that right now.
All of the homework for all of week 1 is due Thursday instead of Monday, right?
No. Only chapter 1.
Oh,
Only chapter 1 is due Thursday. 2.1 is due 2.1, 2.2, and 3.1 are due on Monday.
cool. Thank you.
Yes. So chapter 1 is the only thing due Thursday, and it's pretty quick. A few of you have done it already, I think. It's pretty quick. And it's all like vocabulary stuff. So you should be able to finish it like when we get done with this class, since you'd scheduled yourself until 7:50. If you just jump in and finish it, it might take you 10 minutes max, maybe not even that. So it's pretty fast. Anyone else? All right, I'm going to turn off the recording.